All right, thanks so much. We're so excited that everyone's here for Construction Tech tonight and to see the presentation by the team from Monadnock Construction. Passive House Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction tech. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're happy you're here. Thank you.
Zach, that was wonderful. And for those that missed the policy summit last night, go to Passive House Accelerator's new website and to the YouTube page. In a few days, it will be up. It is an entertaining and inspirational policy summit, not one that puts you to sleep and drives you away. So please check it out. And last night before the summit, we were blessed by having a run through of tonight's presentation. So I really invite you to focus in on what the presenters are covering today, because the level of detail they explore from the mock-up stages and the sheer volume of square footage they've been able to accomplish is tremendously insightful and very inspiring. So I pass the mic to the next host, and I welcome you all this evening.
I second that wonderful review of last night's not only dry run, but the summit, both fantastic. It was a great night. I'm getting excited for tonight to see all those transitions and details all over again and the massive scale for multifamily and the lessons learned. And I'm Shannon Pendleton. I'm in New Hope, Pennsylvania. I'm a passive house consultant, and I'm coming from the East Coast. For those of you who haven't seen the new Passive House Accelerator website, if you're trying to convince your client to go passive house, there's some really great tools that are open source there for you to use. So welcome, join us.
Thanks, Shannon, and thanks, Mr. Wyoming Willie. For those that don't know, Mark got a new cell phone number, and it's out of Wyoming. He hasn't moved there, but if you know Mark, we don't really know wherever he is. He's somewhere on this planet. Sometimes he's not on this planet, but we like having him. And I would like to just comment about 7 days ago, Mr. Bob, aka Brickhouse, gave an excellent presentation. If you missed it, go check it out again. The Accelerator has all of the previous events on the website and also on the YouTube channel. But I have to tell you this, I have been looking at brick in Vancouver very differently. I also appreciate that brick in Vancouver is really more of as a cladding and not as a structure. So I definitely looked at the details. So Bob, thank you for letting me dive into a part of the envelope that I didn't know about, and you are a master. And so I am now great to come back to the future to change things out and see what we're going to learn here tonight. So thank you for joining us, and let's move it on over to Kevin.
Nice, thanks, Sean. So just want to thank everyone for being on the call tonight. It's a great privilege and an honor to have Alex, Cheyenne, and Shazad on the call to talk about their massive passive house project at 425 Grand Concourse. I first was introduced to Monadnock Construction while I had the privilege of teaching them. Their construction managers, their assistant supers, their on the floor superintendents, the passive house tradesperson course as they were going through the Cornell Tech project. They brought me in afternoons and weekends, and we covered the entire passive house tradesperson curriculum. We did a quick little mock-up outside, and then we did one of the floors on the project. And it was a great eye-opening experience. And then after they all got certified, the entire team passed the exam. And then as they were going up the building, they said, "Hey, Kev, would you help us, look at some details and come here a few days a week?" And I was like, I would be honored to work on the project. And it's a great honor to drive by that project, go over the 59th Street Bridge and be like, I had a part in helping that building rise as quick as it did, as fast as it did. Not only beautiful, but it is one of the largest passive house projects out there. And now every time I drive throughout the city, I keep seeing Monadnock buildings that are passive house. So I'm going to let Alex and the team explain how they get there. And I'd like to point out that it's the culture of Monadnock for excellence and execution and construction processes and just a different standard that I notice on sites, and they obviously have it. So I'll kick it over to you, Alex. Thank you very much.
Thank you for having us tonight. We're lucky to have a video on. Up to last minute, the camera just stopped working. So things are working out. Kevin, thanks for the good words. You underestimated yourself. I think you were involved not only in the Cornell project, but in every passive house project we built. But we'll touch on that later on. Everyone, so I'm Alex Elizarov.
I'm Cheyenne. I'm Shazad.
We'll be sharing our experience about passive house. But before we get started, I'd like to give credit to the project team who are not on this presentation, but might be listening to the podcast. It takes a team of professionals working together to build a job, and we're lucky to have a team we have here. I'd like to thank Trinity Financials, MBD, New York City Department of Housing Preservation and Development, HPD, to make this project come alive. I'd like to thank Datna Architects, DAG Engineering, SWA, Broad Power, DeSimone, Case, and other consultants for working together to this point, getting the project to where it is right now, to this stage. A lot of work has been completed. We still have a lot of work to do to finish it, but I'm sure we'll continue working together and finish it strong. With that said, I'd like to introduce Monadnock Construction to the listeners. Monadnock has been in the business for over 45 years. We actually started as a masonry contractor and then quickly moved to general contracting, real estate development, and construction management business. We predominantly concentrate on residential construction, residential high-rise construction, high and mid-rise construction. We also build dormitory. We build some commercial. We do market buildings and affordable buildings as well. And in around 2015, we were chosen to be a builder for the famous Cornell Tech project that spearheaded the passive house movement in the United States. Since then, Monadnock's experience in high-rise construction, high-rise passive house construction, expanded to over 1.5 million gross square feet. As you can see on the screen, we have a Cornell Tech project, which was a mega prefabricated panels and a cast-in-place structure, completed and certified with PHI. We had a Morris 2 project, which was a cast-in-place structure with EFS facade, completed and certified with FIAS. We just completed 1240 Metcalf project and passed the final passive house test in February. With Bright Power, it's a block and plank building with brick facade, masonry facade. We are in progress building 425 Grand Concourse. We're going to be talking today about this project in more details, which is a field installed panels. Betances, it's a mix of panels and brick, certified with PHI or being certified with PHI. Vital Brookdale is under construction in the superstructure stages. It's a masonry block and plank building, and the Blake buildings A and B are in pre-construction. So we are committed to what we do. We want to continue building better, greener buildings, and we hope to pave the road ahead for other contractors to do the same. In today's presentation, we didn't know how to start this presentation, and we kind of want to share our pointers and things that we learned from past projects that help us succeed in building the high-rise passive house buildings. And we in any jobs, we have to, contractor has to achieve, 3 objectives: build a quality project, deliver it on the schedule, and under budget and on time. But in the passive house project, it's more important, and the contractor's commitment from the beginning of the job, from early construction stages, is vital to the project success. So in today's presentation, we're going to be talking about passive house, schedule coordination and cost, and teamwork, and how all of that come together, and how for all the contractors, it's important to bring their feedback, their say to the table, along with the designers and the team, and plan that project together as a team, from early stages of the job. And that's going to come up, and starting from coordinating how you're going to erect the building, what's the best constructability of the building, what's the best logistics of the building, what the best material selection for the schedule, and how are you going to control the QA and QC processes. And all those things have to be discussed with the designers and with the consultants in the beginning of the job, so they can understand what you're looking for, because everybody has the same goal, is to build a passive house job, to bring that project alive. And that teamwork, where everyone gives in a little bit, right? Everyone doesn't get everything they want. I don't, construction, Monadnock, we don't get all the details the way we want to build it. And the designer gives in a little bit. They don't get all the design, and the owner gives it a little bit. They want to build the best project, but sometimes it's not possible due to cost and affordability. So if everyone gives in a little bit and put their heads together, that's when the jobs can become a success. And that needs to start early from the pre-construction stages. So starting on the pre-construction stage, and it actually evolves from the experience. And what we tried to do in Monadnock, we tried to learn on the past projects what worked, what didn't work, what difficulties we have with certain systems. And what worked, we tried to keep it, move into the next job. What didn't work, we tried to create it another way. And it doesn't mean it doesn't work, that we made it work, but if we think there's an easier way to do it next time, we want to bring it to the table earlier to speak to the design team, so it can be done more efficiently. Starting from the evaluating schedule, cost, and constructability. From the early stages, and we'll be speaking specifically about Grand Concourse project. So on the Grand Concourse project, when we got involved, the designers the design team were thinking about this job as a prefabricated panel, similar to how Cornell was done. From completing a prefab panel project, there's a lot of risk and cost associated with the prefabricated project. The prefabricated mega panels get manufactured offsite, and any delays in either production, deliveries, any mistakes in panel assembly would delay enclosure of the facade. And if the facade gets, if the closure of the facade gets delayed, then there's nothing that you can do on the interiors. You can't build your kitchen and bathrooms. You can't do sheetrock leveling or any type of finishes. So in a way, if the facade gets delayed, your whole project gets delayed. Another thing is the cost. There's only a limited amount of, I think, about 3 qualified mega panel manufacturers who can produce that type of panel. And obviously the cost is high because there's a lot of QA/QC procedures. And you also need a tower crane to erect the job. So as soon as we got involved, we have a strong pre-construction department led by my partner, Alphonse Lembo, and his team. So we looked at the superstructure of the job, and it was at the borderline where we thought we can build this job without the tower crane. It was a close call, a real close call. We want to show you a video of how a final pick that was done on the job and how close the tower crane. I think we have a little delay with the data here. Let's try it again. You can see how that crane was in the foot of the building, making that final pick of the elevator machine room. And that's me saying how tight it is. So that was a close call, but we were able to figure out to build that superstructure without tower crane, and then it raised the question, well, what should we explore at field installed panels? And coming from the job where we were completing at that time, we already completed Cornell, we were in process building Morris 2 project, which is field installed EFOS panels, where we use a similar system where we install a CMU facade from the inside. And we said, well, why don't we explore the same, doing a field installed panels, some kind of a facade that we can separate the critical path and separate the panel installation from the interior sequences. This way, there's any delay on the panels or any kind of exterior inspection that needed to be done that takes a long time, we don't have to wait for enclosure of the building. We can proceed with our interior program while taking our time to do a quality job on a facade installation air and moisture barrier installation. So by talking to the design team, presented it to them, they were very open, and thankfully they were very open to it. And they had to redesign a lot of the drawings and redraw a lot of the details. And I'm giving them a lot of credit for following along and trusting us on this guidance. And in hindsight, looking back, we didn't know that COVID is going to hit us. But these panels would have to, if we would stay with mega panels, these panels would have to be fabricated right about from March to December. We are 100% sure that these panels would never make the job where it needed to hit the job, which was January, and we wouldn't be in the situation in terms of schedule where we are on the job right now. We probably would be getting our first panel right about now, where at this point we're sheetrocking on upper floors. So that was a wise decision. This is exactly the things that we were afraid when we were evaluating the mega panels, and looking back, that was a wise decision. So we're going to talk about in details, we want to touch base in details why the field installed panels worked on our project better. That's what Cheyenne is going to explain, that sequence and how we separated the critical path from interiors from the exterior. So I'll let Cheyenne explain it in a little more detail.
Right. So as a contractor, we firmly believe pre-planning in the early stage is the key to success over here. And I'm going to walk through the process, how we plan out this job, how we figure out the sequence of installation. As an example, how we plan out the seeds from the very beginning, very get-go. So from the first tray, who's going to go into the project is the superstructure contractor, who's going to finish the slab. And at that point, we can already start the CMU wall installation. The reason we chose CMU wall installation for the job is a passive house job. Comparing CMU wall and regular stud wall, there are fewer holes and fewer joints to fill in. It's better for the performance. And B, since we already have a precast lintel on this job, we can use scaffolds, and the scaffold will tie into the precast lintel instead of as a brace. The reason we don't tie into the slab on this particular job is because we have a bigger spandrel panel at the slab edge. If we tie into the slab, which will leave out these panels to a later stage, this would have a bigger impact to the schedule later on. So try to steer away from that. We said, why don't we brace to the spandrel to the precast lintel and then tie it from the inside to the slab. That way we can save a little bit more time and do more work in the beginning. So those are the reasons why we choose CMU wall installation. That also ties into we are able to use the scaffold, and we steer away from the tower crane for the installation as well. So after that, we treat the window opening with metal clad, and all these activities can be done from inside the building. Then we install we do the window installation, and we are able to seal the window from the inside. And at this point, the building is watertight to be able to start interior work, which you can see over here. We're able to do the interior framing, start the MEP work early on, and we can even start the sheetrock operation. On the outside, meanwhile, we have the precast lintel to tie into. That's where we can climb up the scaffold installation, set up a platform for the exterior panel contractor to work on. And we are doing the vapor barrier on the outside, which gonna slowly following the progress of the window installation and the CMU wall installation. Then we have all the brackets, rail installation, and panel installation following through. There are a couple of benefits for doing that. One major thing is it allows the interior build out to start early, to separate the critical paths, separate out of the critical paths of relying on the exterior trade to finish, so we can enclose the building a little bit early on. So all these is what we figure early, on the pre-planning stage. And here we have a couple of pictures how it actually carries out in the field. So for the CMU wall installation, we're able to set up control access zone, do it from everybody tie off, do the work from inside, and we're able to use the lifts to install the precast lintel from the inside and the metal clad installation as well. You can see all the window contractor is putting the window in this picture, and and the window can be caulked. And over here, the interior workers are starting. You can see already framed out, exterior framing is done. And meanwhile, on the outside, the same stage of the job, on the outside, you can see a clear division between the trades. You have the superstructure trades on the top, CMU wall trades following, precast lintel, and metal clad installation, window installation, and the scaffold. You can see over here, it may be a little bit hard to see, but behind the scaffold, the netting, you can see the vapor barrier on the wall is going in. The framing of the metal panel is going in. And on this picture, we're turning around the elevation of the panel installation starting from north of the building. So you can see clearly a division between the trades, and it also established a cycle for the contractors to follow through. Once they establish a cycle, it's easier for everybody to keep on the schedule, and it drives the previous trades ahead. So the trades are, for example, over here, the window contractors are already catching up on the metal clad installation. That's the sign that somebody ahead should already catch up. So that's what we planned in the beginning, and that's how it's carried out in the field. So schedule is one thing, and we are also very high on maintaining the quality control and QC procedure. That's where Shirzad will discuss more in detail.
Before we go into schedule and QA/QC procedures, so one thing to note on this photo, you can see the panels, the photo to the right. You can see the panels already start on the bottom, but the building did not top out yet. With mega panels, because you have used to tower crane to install the panels, you would see right now just a cast-in-place building with a lot of orange netting, waiting to top out, and then the mega panels only come in, and you start after you finish the structure, you start installing the mega panels. So you can see how much ahead it got us, you know, ahead of the before we topped out the building, how much work was completed. Whereas in the mega panel case, which would cost more money, require a tower crane, we would be that much behind. So just wanted to point that out. Going into QA/QC, Shirzad is going to speak about that.
All right, so Alex and Cheyenne talked about big picture, which is great. So we're gonna go more into details now, as Alex and Cheyenne mentioned before, the planning and trying to figure out the details is very important for us, and QA/QC is very important for us. And the mock-up is one of the part of the QA/QC, and we as a company believe that every contractor, every job has to have a mock-up to work out the details and go through the installation process and see what are the things that were missed during the design phase or during the planning phase. So these are the two mock-ups we built on site. One of the mock-up we built with a CMU wall. We talked about it. CMU wall. And we used the specified waterproofing for the first mock-up, which is a gray one, which was a Henry Air Block 17 MR, and we found a few problems with that. The first thing is we had to apply 3-4 coats or 2-3 coats to get the result we wanted, and to meet all the requirements we wanted, to fill in the holes, to fill in the joints, to get the specified mill thickness and the coat thickness. So in the mid of the building the first mock-up, based on the previous project, we were building the Metcalf 1240 Metcalf at the time, and at the 1240 Metcalf, we switched to from Henry Air Block 17 MR to STP. So in the midst of building this mock-up, we also decided to switch to STP, which we thought is better product. It's a faster application. We can apply this product in lower temperatures. We can with this product can be applied on a damp surface, and there are a lot of pluses on pluses about application of this product, I guess. And another thing was thought out in the design process was switching Blueskin to metal clad. So metal clad has a lot of advances, which are we can install the product and leave out for a long time. It can be exposed to UV. It can stay longer, and we don't have to worry about fixing it later. We also did a couple of tests to make sure everything works. We installed UPVC windows, sealed it, installed the insulation. Another thing we switched out were the insulation pins. Before we were using metal insulation pins. Then we switched out to round-set Insulfast insulation fastening system, which was installed after installation. After you put the insulation onto the wall, and you just shoot the pin, and it has a very small nail, which basically there's no penetration in the air barrier system. So this is hopefully video works. This is how we apply Airblock STP product. This product was actually recommended by Kevin Brennan, which we appreciate a lot.
So one of the things I want to mention about the product, this STP product is a great product, but it's more expensive. So we have a contractor work with us, the panel installer. We convinced them, and it's the truth. He saw it actually. He was involved with us to get figuring out the mock-up, and he saw that his application to reach the proper millness was 2 or 3 times. It was he had to apply the original product 2 or 3 times to reach the proper thickness. So when we introduced him, we showed him this product. We said, look, if this product costs more money, and Kevin was involved saying, look, but you can apply it with the power roller. It'll save you on the labor. So you save on the labor, you get better quality product, you pay a little bit more for the material, but overall you should be even, or you should come out even, or save money. And the contract, PG contracting, very reliable panel installer. He understood that quickly, and he also committed to the quality of the project. And he saw that the way this product covers the block wall and seals all the little pinholes, and he quickly switched to our product, and we went ahead right with it. And the design team obviously, evaluated. We had all the compatibility reports, and we went along with it.
Yeah, and as you can see, this product can be applied it can be spray applied or power roller applied, which is much faster than applying the Henry Airblock 17MR with the brush or. So here we can talk about, we're going to talk about more details, some of the transition details we want to talk about. This detail specifically, this is at the roof, at the terrace. This is transition from the roof membrane to the air barrier. Here we have a liquid roofing membrane overlapped by the STP air barrier, and we have aluminum flashing being installed, and we're sealing joints. You can see some of the framing is being installed, and some of the penetrations will be sealed. And here's the detail we used. We have an AAC block because it's passive house. This is a thermally broken system. So in order to insulate the base of the building, this is a very good product to use to transition from roofing to the air membrane. Yeah, to have continuous installation. This detail, this condition shows this building actually has a lot of ins and outs. It has a lot of penetrations. We have this is the framing at the inside we have on one of the upper floors. So as you can see, there's a lot of framing. So there's an inset here. There's sunshade brackets. There's a thermal block here. So all this needs to be waterproofed, thermally broken, properly sealed. So we have to make sure this framing is not touching the wall. And after we install this, we install the insulation to make sure the R value meets the specified R value to meet the passive house requirements. Here you can see how we're waterproofing the sunshade brackets with the blue skin. We're waterproofing all around, sealing it to make sure it's watertight and airtight. Here's some details we have from the shop drawings to show all that. The details at the windows. Window head flashing is another very critical area where we have to make sure we waterproof it properly. We have aluminum metal flashing, which is overlapped with the blue skin at the top, sealed all around, and aluminum itself is thermally broken from the behind. And all this done obviously after sealing the windows. You can see the detail here. You can see the metal flashing, sealed window, the waterproofing and insulation.
One of the things is because we set the windows flush with in order to proceed with this type of construction, we set the windows flush with the exterior CMU. The design encompass overlap in the insulation over the cork joints. And I think one of the next slides is going to show that in more detail.
You can see it here. You can see how the window is sealed from the outside. This is exterior window joint. This is metal clad, which we installed from the inside. And the air block STP overlaps over the metal clad to provide continuous air barrier to make sure it's airtight and watertight. And here, there's insulation over the window joint to make sure there's a thermal break and overlap for overlap of the insulation over the window joint. We have to make sure, we also have to make sure the framing doesn't touch the window itself. Otherwise, there's no point of installing the insulation. There's going to be thermal break. So you can see the gap at the side of the framing. You can see the insulation. So next slide. This is a window from the inside. We want to point out a couple of interesting detail from the inside. This is a window which is already sealed. Window seal is completed on this. We used UPVC windows, and the straps on these windows are very small, 3/4 inch, 1 inch straps, metal straps, which have a lot of holes for installation purposes. Not sure if you can see it here, but you can see some straps here. We requested the installer to use some solid shims to make sure, instead of horseshoe shims, so to make sure it's sealed properly, so sealant doesn't go through the holes between the horseshoe, the hole in the horseshoe. So all this sealed properly, continuously, and then we install the framing on the inside. This helps out to advance with the interior framing and install the sheetrock. This framing is attached on the back side of the CMU. And there's no attachments on the jamb, so we made sure there's no penetration through the sealant at the jambs to avoid any mistakes from the contractor. And you can see the final product here with the sheetrock already.
We want to point out, when we approach on any of the job on a big scale, when you have a lot of square footage to walk or inspect, there is no way how to put enough eyes or have enough people to watch every inch of the building where it's getting installed. So the choice of your materials and means and method has to be self-reliable. So starting with like block, for example, right, versus the gypsum exterior wall. If an installer puts a screw through the gypsum wall and he doesn't hit the stud and he pulls it out, he might forget to seal that screw. We might never see it. And then there's an air leakage, right, that we'll find out in the end of the job. It happens on some of the other jobs, non-passive house, where we had water leaks from the exterior gypsum wall. Therefore, CMU kind of self-prevents that. The STP material, it applied thick, one layer. It's, you know, power roller. It kind of guarantees, even though we have the QA/QC program, we walk and mark out if we see any pinholes. But in, you know, neither the consultant inspectors, neither do us, can be in every inch of the building. So those materials that we try to choose, we tried for the materials to perform at, you know, to prevent any kind of installer mistakes, right? Automatically perform installer mistakes. And on those angles, specific angles, so these angles, they don't need to be there for framing. What we installed there after the window gets installed, that metal clad window surround vapor barrier, it's exposed for a little bit right up until the sheetrock gets installed. So trades can damage it. Somebody can hit it with a knife, you know, bump it with the stud in it and damage that insulation. So to prevent that damage from early on, as soon as it gets sealed, we put those 4 angles around perimeter of the building. It's above and beyond that's needed, but it provides a level of protection that we don't have to worry about, right? And the whole point is to use the material to come up with methods where you don't have to worry about, because there never can be enough eyes. And if a contractor does not take a lead on it on their own, that's not going to be in the design drawings. Each contractor has to think about it, think about the material they want to use, the means and method, and the QA and QC protocols, and establish those protocols early on, because otherwise the results can be a failure in the end on the final test.
Yeah, and the contractors need to be, we have to speak to contractors and coordinate with contractors and guide them, because some of the contractors never built passive house, so we had to explain what a passive house is, how to build it, and what to avoid. And some of the things we had to talk here, there's sealed brackets, sealed straps at the inside. So when they had to install the sheetrock, they didn't penetrate the sealant with the screws. So this was also very important, and space the screws properly. Some of the slides, I put in some of the slides with masonry to show the masonry conditions, some of the masonry conditions, how it transitioned from the parapet wall to the shelf angles. We used blue skin. We used ferrous system, which can be insulated in between and behind, and then use the blue skin TWF to flash over and transition to Blueskin SA. Blueskin SA is actually, you can see here, an STP was applied before installing the ferrous system. So it's all continuous, and even if something happens to the TWF, there's a second layer of protection in the back, which I think is also, which is great detail, and which is going to be very helpful in the future. And the parapet itself, we used the STPE, which is going to transition to the parapet wall at the top of the Blueskin again. So you can see some of the thermally broken brick clips with sealed tips. We made sure these are all the penetrations are sealed, and all the clips are thermally broken. Here are some, well, like we said before, QA/QC is very important, and design team and consultants helped us, and manufacturers help, always on site and watch and help us to monitor and it's a additional quality control. So some of the pictures show here, let's say this one, sealant adhesion testing. This is the Simone doing the sealant adhesion testing to make sure the sealant adhered properly to the UPVC window and metal clad, to make sure the substrate is cleaned properly. And sealant obviously performing properly. Next picture shows how we as a contractor make sure that the air barrier is applied properly with no holes, the right mill thickness. Also, installer does the same thing. So they go through, check all the pinholes, mark it up, and check the mill thickness. We did some window testing, which is specified for the project. This is a window, air, and water testing. which is very typical, is done on most of the project, which is very good. And also air testing for the air barrier in the windows, which is required for passive house. At the top right, you can see how roofing manufacturer making sure and doing adhesion testing and making sure the products is adhering to the substrate. Here are some videos. This is Kevin doing some air testing or testing on the air barrier to make sure, spot checking to make sure there are no leaks, or if there are any leaks, we can fix it.
You were at 250, I think.
And this is seal and adhesion testing that DC1 is conducting. We did this on every floor to make sure sealant is applied properly on every floor. And that's it.
So, this is, we wanted to show you a video. Well, number one, we want to say special thanks to our 425 Grand Concourse field team that works 6 days a week, a lot of overtime and watch those details and to make this job come true. It's Billy Styler, Mike Sullivan, Tommy, Barker, Ariel, Alberto, Kennedy, Luigi, and all our contractors. Again, this is not a one contractor job. There's a lot of people involved on a consultant, design, ownership end to make a job come true. And I want to make sure we will remember they're being recognized. And special thanks to Kevin Brennan. He's the one who got us certified, a lot of the Monadnock staff certified, and kind of introduced us to the passive house principles, and we carry the torch along. And to kind of sum it up, how this system go together, we have a final video, time-lapse video from last year. I think it started last March to now. It's only been 15 months since the job broke ground, started foundation with the full cellar through COVID. And this is where we are. You can see it in 30 seconds. So this is, and you can see the superstructure goes along. And then the block starts as we described, and the windows and the scaffold went in, and the sequence, continues. So right now, the scaffold is fully up on around the whole building, and you can see the white area is the panels. The panels about complete midway up the building, and we're pushing ahead, hopefully for TCO, beginning of next year, and occupancy shortly right after. If you guys have any questions, please, and maybe sorry for taking us longer than 15 minutes.
No, you're fine, Alex. Thank you very much. Amazing presentation, Shahzad. Cheyenne, thank you very much. Great job. The thing I'd like to just point out is the incredible teamwork you guys put together. You get contractors, you get the most out of them, and you get people to get this buy-in that the project's worth value of putting everything in. So you guys do a great job at that. And for you guys that couldn't tell, Shahzad is very technical for a reason. He used to be a recovering envelope consultant, I believe. So he's just as nerdy and technical as I am. So I always appreciate being around him.
We met Shahzad on one of the passive house project on Morris, where he was a consultant for us, and consultant inspecting our work, and he liked us so much that he switched to the contractor side.
Yeah, I've seen a lot of contractors, and Monadnock was one of the best ones I've seen. So
it's something about the culture at Monadnock that everyone gets a true enjoyment out of building something that's bigger than themselves. It's this sense of accomplishment. Everyone's very proud when I walk those floors, and I think Passive House brings that next level to your team of we're very proud to build Passive House, but it's that level of excellence that you can't hide from the blow a door, and sealed is sealed, and thermally broken is thermally broken. So you guys do a great job.
Thank you.
Thank you.
How do we look on questions, guys?
All right.
There's a lot. So Shannon, why don't you dive into it? Unless Mark, do you have any Any comments?
Render myself speechless still. So often we focus on Passive House and trying to bring the message home to folks. If anyone was involved in commercial construction, they would learn so much by the timing, sequencing, and just impeccable nature of your management and execution, that you wouldn't have to bring up Passive House in the conversation, because the quality of construction is the leading edge of what you're doing, and Passive House would be an added gift to the building owner. So bless your hearts for this inspirational project.
Mark, just to add on to there, anytime you go to Monadnock, you'll be there at their office early in the morning. They're having meetings with all their site supers. There's a lot of coffee being thrown around. And the meetings and the planning and staying ahead of the project is something they take great quality in. The other thing I forgot to mention, or not really forgot to mention, but just to call out, that pretty soon the team, Stephen Winters and the design team, will be doing a blower door test on this project. So that's where it really gets exciting. And collectively, over the 1.5 million square feet of Passive House, they've had great success. They've gotten tighter and tighter with each project. So they've done great jobs. I think Mike O'Donnell's on the call. So hopefully in the next chapter of this building, we'll be testing it. And that in one of Shahzad's pictures, he showed an air barrier being tested on the outside. That's a little bit of an innovation that that Stephen Winters did on this project, to be able to get a test on the facade without having to do a guarded blower door test like we've done on other projects. So there's been quite a bit of innovation and shared lessons learned there. So.
Yeah, so to kind of piggyback a little bit on Alex, before, not everyone could get everything they want, right? So we were talking about doing a guarded test, which is what we tried at Cornell, and thought that would be a good idea, but it wasn't going to necessarily work for the schedule here. So we came up with other ideas of how we can still do some testing, but not really impact the sequence as much. So we've decided to take large sections and chunks of facade, 30 feet or so we get some windows and some air barrier and kind of get some numbers, see how we're doing as we go up the building. So that's been a new thing for us. We haven't really done that before, but it's kind of working with the team, seeing how we could still kind of achieve what we're trying to do without killing ourselves with the schedule and the construction status. So and I've been working very closely with Shahzad, walking around, looking at the facade. He's got his colored markers, circling air barrier spots, the installers circling stuff. So, there's also Simone looking at stuff. So there's just so many levels of people looking at stuff that it's almost impossible to get away with stuff you could probably get away with on some smaller jobs with not so many people on it. So to date, it's definitely been a great project to be involved with.
Thanks, Mike. Appreciate you being on. Sean, you got anything to add? Shannon?
We have a whole bunch of questions, and please keep them coming. I know a lot of us were rendered speechless by the sheer scale and the fire hose of information that we were just drinking from, to see the incredible coordination and sequencing of events that was going on the outside and on the inside. And I have a lot of questions myself, but I'll hold mine to the end. But I want to mention something that this team said last night when they were doing the dry run that I'm not sure they shared with everyone during their presentation. There were a lot of kernels of truth, but one of the ones that I thought was brilliant was they said, you can't expect that everything will be shown or spec'd, shown on the drawings or spec'd in the specifications. They said the contractor has to bring things to the table. And this project, it's mind-blowing how much the contractors brought to the table for this project. So our first questions are from a couple of Peters out there. One is Peter Schmelzer, who may have left our chat, but we also have Peter Molnar. So Peter Schmelzer, if you are here, would you like to ask your question? And if not, I will ask it for you.
My question is the aluminum flashing detail at the roof transition from the upper wall. Was that bent at 90 degrees or was it bent at 92 to allow for water runoff?
There's a low slope. There's a low slope in the curb itself, and there is a low slope in the aluminum flashing. So we consider that and make sure condensation occurs in the panel system, runs down and drips off.
And the question from the other Peter, who seems to have left the chat, was for FIAS and FEE, the mix slants towards FIAS. They asked, do you think that will continue, or will more PHI projects be added to your resume?
We are not the decision makers on which certification the developer decides to go with. So I can't say which the FIAS or PHI or which way the project is going to go. We work with both. Both has, I don't know, pluses or minuses is the right thing to say, but both has, its quirks. We rely on consultants, the passive house consultants, to pick the best path for the project, and we just work with the cards we dealt with, so sort of speaking. So that's not up to us to decide.
I'm going to follow that up with to ask if you see a big difference in the testing and verification between the two.
I think FIAS we did several projects with FIAS, and the FIAS procedures and verification got stricter and stricter. The PHI job we're doing, actually, it's a great, I hate to punt it to Mike, but Mike is involved on both our job and many other jobs, working with testing on FIAS in PHI. I think he'll be more qualified to answer that question. And from the contract perspective, they both testing are hard to achieve. We don't change based on PHI or FIAS. We take the same level of accuracy, trying to get that bulletproof air barrier and work out the details. But I think Mike can give you a little more details because
sure. Yeah. So these projects definitely have more testing requirements. We have compartmentalization, lower door testing that we need to do. If there's in-unit ducted heating and cooling systems, we have to do duct tightness testing on those. There's a lot of final verification for either plus or these other overlap programs that are layered on top of FIAS. So there's definitely more testing that's involved, but Monadnock is used to blower door testing of apartment units anyway. They had to do that before Passive House, so that's not really anything new for them. They're used to duct tightness testing if that applies. So it's not anything new or difficult. It's just, again, kind of decision early from the project team on which pathway they want to take. But it's not that much more difficult. I don't think. It's more work for us, more testing that we do, but I don't think it's necessarily harder to achieve.
Mike, thank you so much. That's very comprehensive, and I'm sure a lot of people appreciate that perspective.
Sure.
So we also had a question from Patricia. She asked me to ask it for her. She wanted to know what connections you used for attaching the insulation to the block. I know you showed some thermally broken ties. Is that what you used in the insulation as well?
Yeah, we used for brick masonry, we used Heckman building products. It's a thermally broken brick tie, and for the metal panels, we use Ramsed Insulfast fastening system. So you can shoot it, and it has a little nail at the end, and it goes into the CMU, but the penetration is so small, there's almost no penetration, which is very great, and it's thermally broken. It's plastic.
And these fasteners, they hold up much better. They hold up much better than the glued pins, and they actually have a thermal study.
Oh yeah, they have
thermal analysis.
Thermal analysis,
and
absolutely.
Obviously SWA had to review it, and we like that product a lot. And actually, that was That was proposed by our contractor, by our subcontractor, during the planning stage of the mock-up.
Yeah.
Oh, nice.
Yeah.
Yeah, it makes the process so much faster.
Can you talk a little bit about that process? Because you're obviously in so much earlier because of the contributions that you're making. And I noticed that you swapped out the mock-up in the middle of your 3 intersecting circle diagram from last night. The mock-up was in the middle, and tonight the teamwork was in the middle.
Well, because a lot of it comes out when we talked about it, a lot of it comes out to the teamwork, not only the teamwork from designers, consultant, the contractor. It has to be the teamwork within the contractor's team, with your subcontractors. You know, we have those discussions early on from the buyout meetings. They see our commitment to the project, to the final results. And, you know, believe it or not, once people understand what passive house is and what we're trying to achieve, they get on board. They want to build a quality job. They want to be involved on a job that makes a difference. And they come up with ideas. And because you got to pick the brains of the men and women that actually install that work, that do that work, and get some ideas from them. We don't know it all, right? We can learn from job to job, but when you bounce ideas with professionals or people who do it day to day, they can tell you, oh, that's what you want to achieve, but we can do it that way. And they can actually propose something that you never heard of. So it's about communication. It's about bouncing ideas, explaining what are you trying to achieve. It starts from, the design and architect and saying, look, this is what we're trying to achieve and this is why. And then the contractor says, well, maybe we can do it this way. And then you go back and forth. You do the same with a subcontractor. And then you come up with the best detail that works the best for the job. And sometimes it doesn't mean it's the cheapest detail. Sometimes you pay more for the material to get, to save on schedule, to save on production. But, you have to analyze all of it. And that's why teamwork, we thought, is from all perspective is very important in building a successful passive house job.
Nice switch. Thank you so much. I think it's that time of the night where we need to say hello to Zach again.
Right, thank you. And what an incredible project. Thanks so much for presenting it tonight, guys. So everything that we do at the Accelerator happens because we've got sponsors. If we didn't have these sponsors support, none of this would be going on at the Accelerator. So we need to give all these great companies a big shout out. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool, Stocorp, and Zola Windows. Our stakeholder partner is NYSERDA, and our patron sponsors are Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Innotech Windows and Doors, and US Engineered Wood T-Stud. Thank you, sponsors. So our sponsors also support our podcast, and we have a new podcast every week. This podcast episode is with Robin Wark of BC Hydro, and she presents, she was part of the summit last night. In our the conversation she has with Matthew Cutler-Wells, she talks about the BC Step Code and the story behind that, how that amazing piece of policy came together, and lessons learned for the rest of us. Tomorrow at the happy hour, we have a fun presentation by Zaina Talje, who will be presenting about developing passive house and net zero condos in Boston. And we were just going through her presentation with her today. It's really pretty incredible, the work that she's doing, and some really interesting and deep insights about marketing passive house and how to make development of passive house pencil. So don't miss it tomorrow. Next week on Construction Tech, we have Kyle Macht of Macht Architecture presenting about the Two-Full Passive House project. And then our happy hour next week will be with Tim Ian, who will be presenting about the Lexington Parkway Passive House Plus project. That's it for me. With that, I'll hand it back off. Thanks.